If you like this video, make sure to subscribe to our channel and hit the notification bell icon to get the latest updates.
So basically, we'll share this screen. This is basically the MRP live screen on your left and MD01 classic MRP screen on the right. Left side is MD01N, which is the MRP live. Now, we'll discuss the features, and there are certain things which are newly introduced for performance and technical considerations, because the tables are simplified and new tables have been introduced. So that is why, based on that consideration and simplification items that we'll discuss, there has been a lot of changes here. And also the restrictions are there. I mean, previously the things that which we could do with MD01, certain things are not available now. And also there are some ways or provisions have been made through some correction notes and manual adjustments, where we can make certain things which are which the client who are already on ECC6 and want to migrate to S4HANA, and at the same time keep that feature available in S4HANA. For that, we have some adjustments. Very important thing is the custom code remediation or the corrections, and you must know that all classic BAdIs which are available and used in MRP run in MD01 will not work with MD01N, because these are not supporting classic BAdIs, but they are replaced with above managed database procedures, MDP BAdIs. So let us go one by one, the features. So first thing that when we do the MRP run, we can see that we can run for a range of plants. I mean, the scope of planning is not there in MRP Live. In MD01, for planning multiple plants, we have to create a scope of planning and assign it here. But in case of MRP Live, it is automatically adjusted. You can give a range of plants and it will follow the sequence. So the scope of planning is not there. It actually MRP Live will plan all plants in all MRP areas. When we set up this MD01N, MRP procedure, your actually in MRP, classic MRP, first we run that program to make sure that a planning file entries are made. That is, your MDBM table is updated with the materials, with the relevant indicators, like this processing key, create purchase requisition, schedule lines, create MRP list and planning mode, along with the low level code. We have the entries for the materials in the planning file. Otherwise, MRP run will not happen. In case of so to ensure that, we run a program to activate. After activating MRP in a plant, we have to run this program and make sure that the entries are there in the planning file. But later on, if we want to do MRP area planning, we have to again run another program to take these entries from which are there in MDBM to the DBBM table. So that but in MRP Live, this is always available, because whenever, I mean, it is based on MRP area only. So this MDBM and DBBM table, which you can see in your MRP, classic MRP, is now replaced with this table. This table, PPH DBBM. So scope of planning is not necessary here. Another point is the creation indicator. We have the creation indicator for external procurement. We have the purchase requisition or planned orders in classic MRP. In MRP Live, we don't have the planned orders creation anymore. For simplification of the process, there is a relevant simplification item for that. We don't create planned orders directly. It is purchase requisition, which is always created, and for schedule lines, which is always created for external procurement. I mean, and another point is that along with that, when you use planning mode 1, previously what used to happen is that when we do MD03, suppose there is an old quantity and date for an external procurement, I mean requirement. So based on that, some old purchase requisitions are there. Now, when you run MD03 for that material with a new requirement where the date or quantity has changed, your purchase requisition will get deleted and a new requisition will not get deleted. I mean, the same requisition will be adjusted with the quantity. But in case of MRP Live, always the old purchase requisition gets deleted and a new one is created with the new quantity. Actually, the new MRP run, let us discuss on these points first. Second is the MRP list. Suppose you are doing a planning run in MD01N, and after that, in MD05, you want to see the MRP list. It will not happen because MRP list is no longer supported in S4HANA. Actually, the recommendation is to use MD04 only. MD05 is no longer supported. Suppose I run for a material. Sorry. Why it is saying a planning file entry is not made is that the planning file, it was run before, and when we run an MRP in S4HANA also, the planning file entry indicators are reset. Now, after the run, if we try to take the MRP list in S4HANA, we'll see that it will give some message like MRP list does not exist because it is not getting created. No MRP list. So SAP is saying that you have to work with MD04 only. Now, suppose, how do you, in that case, suppose you have some procurement, which are procurements which are created, say, for example, I was discussing regarding this purchase requisition element that is created in classic MRP. Now we have migrated to S4HANA, but there in ECC you have the planned orders. Now, if you want to have this facility in S4HANA, like You want the old PAN orders to be still getting generated in S4HANA after migration because for external procurement and to convert to PR like earlier. So how do you do that? So for that, they have recommended a body. So you can use that body, that is PPH MRP sourcing body. There are a lot of new bodies that are there. I'll give the list of these and the relevant tables which have got changed. So this new body will allow us to change the procurement element type or requirement type and a type of the element, MRP element. If you have to implement that body. So if you have to keep the existing same, I mean, like in the ECC, if the client wants, then we have to implement this body. But please note that these body is again an AMDP body. These are not ABAP codes, but these are actually ABAP managed, but these are database procedures. Which you can consult with your ABAP team and they will be able to provide. So during conversion pre-check, we have to do these checkings. I mean, on the custom codes. Like for say example, there are two materials. One material is set up which supports MD01N. The other material will have to be planned in MD01. Actually, MRP Live will look at materials which are supported for MD01N. So there is a setup also for that. If I we can run this program to check the setup for this and find out which materials cannot be planned with S4HANA and which has to be switched to classic MRP. It does so automatically. I mean, whatever materials which are not applicable for running in MD01N, right now I don't get a list for this material, but let me remove the material. So this report you have to run. So this is the material that MRP type is not relevant for MRP. Let us go to this material. Why this MRP type is not supported? Planning procedure. Let me see what issue category is planning procedure. So if I go to the advanced planning, there is some planning procedure setup must be. So it will have to be planned through not relevant for planning. This is in the advanced planning setup. So this cannot be planned with MD01N. So that way, first you will have to take a...
Sir, Deepak, one question. Can you please go into advanced planning? So it is, can you please go back in advanced planning? Now here mentioned not relevant for planning. So it means it is not relevant for MRP live, right? But it is
Exactly.
relevant for
Exactly.
old MRP, right? Simple MRP
Yeah,
then, huh?
exactly. So that is why this material will not be planned through MD01N, but when we run MD01N, automatically those materials which cannot be handled by MRP Live will get switched over to MD01. Or if there is any problem, we have a report to force MRP Classic, PPH force MRP Classic. I think it is there. Oh, sorry. No, there is a body for that. That will force, that is what I was discussing. So that body will force, in case it is not taken up by MD01, there is a body implementation which will force these materials, whichever we want to plan through MD01 in, to be planned through classic MRP. So that, because this happens, because you have so many enhancements which are available, and none of these are getting supported in S4HANA. So you have to take this help. Like, for example, suppose you have purchase requisitions getting generated from MD01, and we have an enhancement for triggering the workflow for when these purchase requisitions are generated. I have checked that if we use the classic body, it will support in MD02, 3, but not in MD01N. MD01, 2, 3, this will support because this is in classic. But in MRP Live, it will not support. So we have to take that ABAP managed body. And there is a body for that. All the list of above managed bodies are there in those simplification items and related notes. So I hope the material that they will provide will contain the list of all such. Otherwise, I can provide the list. The above managed bodies which were previously working and need to be adjusted are in the area of subcontracting, reading a material receipt requirement, then scheduling of stock transfer requirement. As I've told you, the user defined MRP element, if we had to change the MRP element type from purchase requisition to planned order, PIR related, planning parameter related change, MRP list change, all these were classic bodies were available. Now they have been replaced with the PPH set of bodies or spots with the methods. I mean, we have the list of all these bodies, which we must consider this because lot of these enhancements are already there. And we have to consider this because we have to make a lot of adjustments, mainly in the custom code.
So Deepak, the materials which are relevant for MRP live run, so can we do the simple MRP run for that materials?
Yeah, we can do. That is what I mean. We don't have to do. In fact, all these things are set up as background job, because in MRP Live, we have this program with the variant which is set up as background dot PPH MRP start. This one. So this is basically equivalent is of our MD01N. This we are setting up with the variant as a background job. When we set the variant, we'll get these values. So there are some changes because creation indicators are not there. Another thing that you need to observe is that planning file. You see that this net change planning in planning horizon. In S4HANA, there is no planning horizon. All materials are planned because we are already having optimized database procedures. Everything is running. I mean, reading of the data and calculation of MRP, generating the procurement proposal, that is not being fetched into your application server and it is running on the database. So time is faster anyway. So even if we consider all materials, there will not be performance issues. But in MRP, classic MRP, we have performance issues because of this not having a live run on the database. So that is why this net change planning in planning planning horizon was there, and we had to maintain the planning horizon. It is no longer there in S4HANA. If you look at this table now, previous table, MDBM, DBBM table, you will find that net change planning in planning indicator. But now in S4HANA, this table, this is the table for MRP area, which is and planning file entries in MRP area, which is already set up. You don't have to have told you, you don't have to do. So you see, that's only this indicator is there. Whereas in DBBM table, both the indicators were there, flags. See, this NETPL is no longer there. And now see, in the table level, as we are discussing, previously our MRP header table, that is MDKP, that MDKP table, materials that were not planned, they were saved in the MDKP table with the exception group 8, exception group 8. Now these are in PPH DBBM table. So MDKP table is not having this data now. Various material master, this MDKP table previously used to have various material master attributes. So in HANA, these attributes are already there in MRC table. So that is why they have dispensed with this MDKP. I mean, further data are not getting populated here based on MRP runs. I mean, whatever fields which are already available in MRC are not coming here. But actually some normalizations happen and adjustments. In ECC6, if you look at the MDKP table, there are more data. MRP list table, MDTB is no longer available, but we don't have the, in that case, how do we find the MRP run relevant details? How do we find that later on? If we want, so for that, there is a function module you can try that will give you the relevant details of MRP run, that is MDPX, MDPSX, read API. When you have to execute this function module or generate create a report, and then you will get the MRP run relevant, because you see that the MRP list is not getting generated. Otherwise, SAP's recommendation is that you use the MD04 only, or we can go to the Fiori apps library later, see if there is anything, but there is none for the MRP list. Another feature that I am telling you, you can test in the system. You have this S4HANA access, is that suppose you have a scenario where the aggregation of dependent requirements based on the sales orders, various sales orders. Now, what happens in normal ECC when you click on a dependent requirement for an aggregation of sales order, you will find that sales order number. But here, but the aggregation is coming from different sales orders since it's a BOM component. When you create the planned order, you will get planned order number to which all these dependent requirements are aggregated. When you see that pegging, that you can get when you go to the detailed screen of the ECC6 for that MRP element, that planned order number. But here in S4HANA, no such aggregation happens. So you will not be seeing any planned orders to which it is aggregated. In a planned order field, you will see only a dummy. The planned order number will be replaced with a dummy. Next is the planning horizon. We have already told that the planning horizon is no longer available. S4HANA is actually covers all material demands. It is not limited to the planning horizon. Planning inside the planning horizon is no longer available because we have told that already there is performance improvement. So by including the planning horizon to restrict our materials during our planning, that net change planning in planning horizon indicator is no longer there. So that this additional effort of maintaining this planning horizon table, that is not there anymore. But suppose you want to include your own logic while creating this planning run. There is a BAPI for that, where you include your own logic. That is the BAPI. You have to implement, you have to use this BAPI for including those additional fields. If I test this BAPI, the parameters, you can see material plant, MRP area, planning scenario. So all these you can planning parameters. Here you can maintain the planning parameters. So here, if you look at the planning parameter, here you will find that you can use, already suppose this BAPI you are using in some custom code where you have the net change planning in planning horizon. So when you convert to S4HANA, you must remove that because otherwise it will not support. Whatever I am telling you is the mandatory things we must check while doing the migration from the planning perspective. Each of these BAPI and this list of BAdIs and the parameters which I am mentioning are very important and must be, you should have a full documentation of that. But there are some enhancements which you may have to use. I was talking about a case where we have an old purchase requisition number got generated, and it is always deleted in S/4HANA, and a new number is generated when we are adjusting or changing the requirement quantity or date. But if such thing but in classic MRP, this is already retaining the old numbers. So while converting, if the client requirement is such that they want the old numbers to be retained and make the adjustments there only, which is not there in the sorry, which is not there in S/4HANA, then we have to use a BAdIs. This is important. So this new BAdIs PPH MRP reuse BAdIs. This will retain your old PR numbers and just adjust the quantities. Achha, one more thing that I'll tell you, let me go to that MD01 screen. Just 1 second. Let us go to MD02. This one, this indicator. Now suppose you are running MD01. In MD01, you will have this also plan unchanged components. In classic MRP, it is there. But in case of S/4HANA, if you want to also include the unchanged bombs in your planning run in MD02, when you are running in S/4HANA, you have to ensure certain things. Like you have to check that this configuration is complete. Otherwise, it will only plan the change items. This one. Here it has to be always set as it is already set up here. Enable bomb validity calculation. This is another requirement is there for that one. I'll tell you. And another setting that you have to make. This one is required for making bomb changes with engineering change numbers. When you do that and do the planning run in S/4HANA, you have to make this setting, ensure that this setting is there. And another report you have to run and adjust some text elements. That is your PPH MRP start report. When you run that MRP live, you go to the test element and you have to indicate this checkbox. You go to this selection text for making change, for including bombs which are not changed. Also include unchanged bombs. This indicator must be set. So these text elements under this our MRP lab parameters, this has to be checked. This is a manual activity.
So we can do this thing in each system, or we have to transport this manually. We have to do
manual correction. There is a note for that. These actually all these have been mentioned in the simplification item and notes. These procedures you have to apply. So what I can do, I can share these simplification item numbers and notes with you. But it would have been better if then a documentation is available for you, ready-made. So, I mean, all these list of pre-checks and these pre-migration activities and post-migration activities that you need to carry out for this MRP run, that I mean, step by step, that is needed.
that. You will provide, right?
That they will provide. So after I was talking about this engineering change number. So when we change a BOM with the change number, the valid to date from the change number is not copied in STPO or STKO table in case of S4HANA. So we have to make that. So for that, we have to run a report. Otherwise, this valid to date is not taken. And if it is not taken, then this will not be included. I mean, these bombs will not be included, these materials, in the planning run. So we have to run a report. First thing is that configuration I showed you for the bomb explosion, that has to be set as E as enable bomb validity calculation. And secondly, there is a report, CS bomb valid 2, this one. This we have to execute. This has to be actually executed in background for both first with STPO and then STKO. And these are parameters, values. Where from we will get these values? You will get these values from your performance log of previous runs. I'll check how this is found. It is there somewhere. I have kept it. I'll show you. You will have to use these values. And this has to be run in a background. You will have to set up 2 variants for STPO and then STKO. Once you run this, then in the STKO and STPO table, this valid to date will be copied from the change number, and you will be able to include this in MD01N.
So when we are creating the bomb manually, then the dates will be there only that time of transferring from.
Yeah, this is only applicable in case of you are using the change number. When you are changing the header or material item component with a change number, then you have to make this adjustment.
You have to run this report.
Yeah, twice you have to run for header and item, then this valid 2 is copied. Acha, in S4HANA, regarding the performances, you can get details of previous performances of MRP run. Suppose you have run MD01 or background run MDBT. Then you can get some performance run results of performance log. There are 2 reports for that in classic MRP. Same reports you can run in S4HANA also, and you get all the details of that performance. I mean, whichever materials have been run or selected, failure, any implementation or enhancements were there. So like one is say for our MD01 or MD01N, these two reports you have to run and see the performance. Which one? This one, the statistics of previous run. So you can put a date range, and if you execute, you can enter other parameters also. Actually, this does not have much data. So you will see that last MRP run happened for a plant, and you can get all this. What was the run time? How many bombs were exploded? None, because there are there are failures also. So you can get all the details. What was the processing key? Was there any enhancements? How many bomb explosions whether happened? Which type of scheduling? So all the materials with termination. There are 4 terminations. So this type of performance logs you can have with this report. There is another report. You can run which shows the heat materials. I mean, which materials were selected. That is again MMDP this one, heat list. So you'll get all the materials that were planned with the runtime, and I mean this is the performance statistics you can get. Now regarding some technical parameters adjustment for MRP run, MRP live, you have a report where you can check the present settings, technical values of these parameters. So that is this program. So these are the performance statistics which you can maintain. You can adjust these run times. That is the minimum number of materials to be planned, maximum materials to be planned. This is all related to performance. There are so many parameters here. Now, if you want to adjust these parameters, there is an enhancement spot. That is one enhancement spot or body for, again, this is spot. So that is dispatcher body. So that will give you all the past parameters that the system took, this system performance parameters. And based on the performance of the run, you will get the values of those parameters. There's a method, get parameters in that body, dispatch parameter, get dispatch parameters. So that method will contain all these values. So depending on the performance issues, you can adjust those values here in this report. There are so many, I mean, all these parameters, there are so many things, I mean, all these you can adjust. I'll actually have to send you all these report names and the old classic BAdIs that were available, and the new BAdIs that has replaced those. And in case you have to do the adjustment, you can do adjustment in the old BAdIs also. Acha. And another point is this, important point is this one. In MD01, we have this user exit key. In MD01, obviously, we cannot restrict our materials. When we enter plant or scope of planning, all the materials within that plant or are included. But if we have to select the materials according to some logic, for that we have to use this user exit key. And this user exit key has a standard exit which we use. Now in such case, what will happen when we migrate to S4HANA? First thing, this user exit is not supported in S4HANA. So first thing is that in MD01N we are able to include our plant, and we can have a range of materials and plants. So material restriction with that one is possible. Easy way is to that according to our logic, we can have a set of materials which we can upload here, we can create a variant and use those materials only. Because that user exit key is not available now. But there is an enhancement spot, as I am telling you, PP MRP dispatcher. So in that you can make adjustment and include whatever logic you have entered in this user exit to be working with MRP Live when you activate that body. There are some manual corrections and the corresponding note which is available. Let me show you one thing. One client, just 1 second. This screen, I'm showing you a screen. This one. We have seen the MD01N screen. Now, this is a new MD01N screen that has come up. And that is after implementation of one body where you can see under red. You can also include materials according to your logic, where you can have MRP type wise restriction, MRP group wise restriction, and low level code wise restriction, which you can include in your plan to further improve your performance. Besides that, there are 4 parameters: MIN, HANA, peak size, numerical HANA, numerical above. Now, these parameters, we don't know the meaning as yet. It has come up this January only. This they have provided. I can give you the name of this implementation, and you can try it out with your ABAPR and see. Then we have to test it with these values. All we can see is that further restrictions are possible and flexibility can be brought in. So if we discuss on the MRP live transaction with respect to classic MRP, we say that MRP live is designed to perform large number of materials from the performance issue. It is best understood when we plan a large number of materials. Suppose we run for one material or few materials, then we'll see that we don't see anything. I mean, it is not an improvement. So improvement in performance of MRP live compared to classic MRP depends on the MRP features that we are using. Number of materials to be planned, number of materials not to be planned, because those materials which are not getting planned through MRP live will get switched over to MRP classic. So in that case, runtime will suffer. And excess of low level codes which are getting planned. That is why that enhancement has taken place, and we can further filter out based on the low level code. Regarding the low level code, we know that MRP live normally calls only one low level code for every plant once in its planning run, and that is the optimization. Now whenever what happens is that the number of low level codes is created each time there is a change in BOM. It never decreases, but it always increases the number of low level codes. So over a time and after multiple BOM changes, there will be unnecessary high number of low level codes. So there is again a report which recalculates the low level code, because this is important for the dependent requirement calculation. All these are planned based on the starting from the lowest low level code. Just 1 second. It calculates the low level code for the materials. It will give a log. Why it is not happening? Let's see. There is a recursion here. So that is why low level codes could not be determined. You can check this in your system. I mean, the present number of low level codes or new level. So this is always restricted whenever we run the live MRP. In MRP live also, you can calculate this, but all programs are that we do prior to our run. We can just check the MRP records. Here nothing is coming, but this report is to be run. For checking the MRP records and correcting the records. I mean, this will what it will do unnecessary low level code creation which could have happened over the years, that can be reduced. So these are all performance improvement things. See, there is a 999 low level code for this material. When this 999 is assigned, regarding the planning file entries, we have already discussed that previously in classic MRP. We have to run reports to first enter the planning file entries prior to MRP run, and secondly, after MRP run has happened, to transfer, create planning file entries for MRP area, we have to run another report. So that updates the MDBM and DBBM tables. But in classic, MRP, in live MRP, we don't have, and also we have seen that there is this NET CH indicator is there, PL indicator is not there in the planning file for S4HANA. The setup for planning file entry in S4HANA is run through another report. This is the report which we have already seen. PPH setup MRP records. This can be also run in simulation. Now, besides the simulation, we can have another conversion report where these flags, NATCH, REACL, these flags from the old database table DBBM, these are taken to the PPH DBBM table. This depends on the requirement, whether we need to keep these features which were there in the old client and bring it to the S4HANA system. What is this conversion report? That is the conversion report. Conversion of report from old MRP records to new MRP records. Nothing is converted. This does not have enough data in the client system. we could have seen. We remove plant. Plant must be. This is not running. I mean, means no data is there for conversion from old tables to new tables. So we have already discussed these things. For external procurement or simplified sourcing, there are additional simplification items that we'll discuss tomorrow. What other changes have taken place? We can give a synopsis of that. If we compare different items, say for example, item wise, MRP activation. For S4HANA, by default, all plants are activated and all MRP, all plants are activated and MRP area is also set up. But in ERP, what we do, we have to activate the plant and then run the report. Set up planning file. In I'm doing the synopsis. So processing key, we have seen that NATCH, NUPL, both are available. These two are available in S4HANA. That is regenerative and this. But NATCH is not available. But three are available in ERP, all three. Low level code in S4HANA, we directly read from the material master. And the low level code, additional, I have told you that the additional low level codes get deleted through a report in S4HANA that I showed you. So in case of ERP, it is taken up from the planning file, that is DBBM. But in S4HANA, that is why it is directly read from the material master, Mara table. Table related, I have told you that the planning file entries are in DBBM table, PPH DBBM table. But for that is why, I mean, in S4, in ERP system, we have so many tables. MDBM is for plant, DBBM is for MRP area, for long-term planning, MDBL, plant, then DBBL, MRP area, individual customer table, that is KDBM. So all these tables are there, but that is replaced with a single table, PPH DBBM. Now there was some point regarding the long-term planning, and there are some transactions, MD50 and MD51, regarding WBS planning. But these are actually available in S4HANA, but we have to do some optimization on that. So I'm gathering some more information. I'm simply, I have to check the things. I mean, how the optimization happens and the relevant SAP notes. These can be used. Normally, if we run as it is, these transactions and also the LTP transactions, MS transactions, these are not optimized as of. So we have to optimize this transaction, and then only this will get supported in S4HANA. We'll be able to run. there are certain restrictions in S4HANA which is applicable, which were available in MRP, previous classic MRP, but now no longer available. So I'll take those details, like for materials with period lot sizing procedure, which say number of period more greater than 1, the results of classic MRP and results of MRP live in S4HANA will differ. In classic MRP, what happens is that the date of the earliest requirement for planned material, that determines the start of the period for grouping of the requirement. But in MRP live, the start of the period is determined by the planning date of MRP run. Start of requirement for classic is your earliest requirement date. That is how you start grouping. Start of requirement is the planning run date for S4HANA. That is the start of period, which we mentioned in the lot sizing procedure configuration. So the requirement grouping in case of S4HANA and in case of classic MRP will vary. So planned orders created will ultimately be different with the quantity and dates. Now, second is the number range for planned orders and purchase requisitions, which are output from the MRP run. The number ranges are different. In classic MRP, the same number range interval is used, but the sequence in which the numbers are assigned may be different. The planning run itself is not influenced by this. The planning algorithm of classic MRP or MRP live rather makes what I have told at the beginning, makes no use of the planned order or purchase reuse if different dates or quantities are involved, and a new proposal is created, a new number is created. We can prevent that, and how we can prevent that, or we can incorporate these features of MRP classic that I have already told at the beginning.
Deepak, one question. So when we do the MRP live for the third material or hard material, it will create the purchase requisition, or it will only for the material?
For MRP live, whenever there is an external procurement, always it will be purchase requisition or schedule lines. It
Right,
will
I
never
agree.
be a planned order.
About for the internal requirement.
For the internal requirement, that means you are saying if it is subcontracted, right?
Even if I'm manufacturing some product, you can say.
No, when you are creating a planned order from for internal requirement, it is a planned order, isn't it? So the
No,
purchase requisition is not coming.
no, but you are saying okay, for the external it always creates the purchase requisition, but for internal
It
production,
will be a planned order production. Yeah,
no.
yeah. But there is a way of creating planned orders, that also I have told you, but that has to be done through some body.
Finance. Otherwise, it will create the purchase requisition for the further material also, which we are
Yeah,
producing in house.
yeah. Acha, I have told you that when we are running MRP live, uh, not all materials can be run in MRP live, and we can set this up and check this, which are not possible in MRP live, and automatically that gets shifted to MRP classic in the MRP run. But if you want to do a maximum performance, you should avoid these special planning features to your materials as much as possible. I mean, materials having special planning features may be excluded from the MRP live. So what is the alternative way? There is an alternative way through a transaction, that is MD force MRP classic. Sorry, MD MRP force classic. That will force materials which are not available for running. You will see that this material was not available for running in MRP live. So if we run this transaction, we will be able to run this in classic MRP. I mean, that way we can separate out the materials instead of having the system determine these materials and switch to MRP classic. That will improve the performances. So it is running on MRP classic. So you get this report and you just execute this, solve this issue. No standard solution available. In that case, we have to use somebody.
But can you explain one time more what is the use of this transaction?
Actually, this transaction detects the materials which are not suitable for planning or have restrictions in MRP live. So when you run this transaction, it will have the facility of switching it to MRP classic. This is why we are doing this from the performance perspective, because when we run MRP live and we select all materials, maybe some materials are not suitable for MRP live and they get switched over to MRP classic run, and that actually reduces the performance. So beforehand, we can run this report to segregate materials having these issues and run them by forcing them to run in MRP classic. So that will detect the issue and then try to solve the issue. So these materials we can include in MD01, but this case there is a planning procedure, advanced planning sort of things. So that is why it is not running in MRP classic. Otherwise, you have run in MRP classic. See, the advanced planning we'll discuss later. Now, there are theory apps also which will detect MRP master data issues that we'll discuss during theory app, which can be run to see which materials are not suitable for MRP live. Now, what are the restrictions that MRP live detect normally? One is certain things are not supported. Say, for example, the lot sizing procedures, certain lot sizing procedures are not supported. See, period-based or cost-based procedures are there. That's optimum lot sizing procedures with period-based. That is least cost procedure, Like this type of procedures, lot sizing procedures are not supported in S4HANA. Like cost-based procedures, part period, balancing, group reorder, these are not normally used, but these procedures are not supported in S4HANA. Optimum lot sizing procedures are there, not period, optimum. So these are also not supported. Regarding quota arrangement, we have two types of quotas, splitting quota and allocation quota. Splitting quota is not supported in S4HANA. Regarding scheduling agreement, when we set up scheduling agreement in the system, there are two scheduling agreement types. One is having a release documentation, with release documentation, and another is without release documentation. So only the one having a release documentation will be, when you create the scheduling agreements, you have to be careful. Without release documentations, this will not be supported in S4HANA. So in case of the legacy has scheduling agreements on S4HANA having no release, no release documentation, you have to delete all this and create again with the release documentation type. MRP type, if I go to the material master, there is this MRP type I have never used. Has anyone used seasonal MRP? In forecast, we have used the forecast types, seasonal. But in case of MRP type, I have not aware. But this is not supported, seasonal MRP. So in this case, you have to use classic MRP procedures for this type of materials. However, this demand-driven MRP, that D1 and D2, D1 is for discrete and process, and D2 for replenishment or repetitive manufacturing. This will be used. Restrictions in other areas like stock transfer requisitions were there, but this has improved. And again, those whenever that is not possible, that transaction force MRP classic, that has to be evoked. Lot of things are there. MRP Live will not participate in materials having AD, subcon. That is more of a plant maintenance type of requirement or refurbishment process. Now there is special procurement restrictions also. For direct production, we have to use classic MRP. If we want to use live MRP on direct production, then if we have to first check whether such materials can be set up as a phantom planning. But from later releases, they have now been changed to and I think it is supported now. It is supported from 1909. there are certain other restrictions. Let me see whether this long time dump or system issues related checks are there. So there are tables, and let me see what materials they are providing. Then I can provide you with a comprehensive things. If because whatever has been discussed over the last hour, these are all important things and must be checked. These are all part of the simplification items, and all these steps we must check in the system and adjust. Let us see some of the changes that have taken place in the material master. For procurement, external procurement, there is a field for quota arrangement usage. If the material is to be considered in MRP and if we maintain a quota file, then we have to make it consider in MRP run. So for that, this quota arrangement usage indicator was there previously in MRP2. But here you will not find that. It is no longer used. Because in classic MRP live, it is always used quota arrangement. So it is not required to switch internal to a material master. Let us go to MRP4. So this indicator for bomb explosion or dependent requirement, this selection method, that is not there. So certain fields are no longer there. You also can see that there was a segment below for a storage location MRP. I mean, storage location to be separately planned or storage location not to be planned, those were there. But now we don't find it. This entire segment is not there. So storage location MRP is replaced with MRP area planning. So these are the changes in the material master. And advanced planning tab we will discuss in detail when we will be running the advanced planning and when we will be filling up this data. Another field, let us check this field, scheduling margin key. Acha, when you do in ECC 6, if you maintain the scheduling margin key, if you don't maintain, then it is not mandatory. But if you maintain, it has become mandatory. But by default, it is not mandatory. In ECC 6, is it mandatory? No. Even if you maintain, it is not mandatory, right? But in S4HANA, it is mandatory if you maintain in configuration. Regarding Production version, we know that it has become mandatory because this will be also a part of advanced planning. So unless the production version is maintained and it is transferred as product data structure, PDS, in the PPDS side, so we cannot do the PPDS run without that. So it has become mandatory, and for simplification reason also, sourcing has become easier, even for external procurement. So BOM is determined via production version only. And can we upgrade the data, upgrade the existing data to have a production version throughout? I mean, whenever there is a change in the BOM. So the latest BOM can be determined via production version. So for that, I think there is a report. This CS BOM provider. This one. So if there is BOM change, so it will take into migration. I mean, when we are selecting the production version, this will migrate. So we have to take care of this one also. So the proposal is to create new production version. So if we select and then execute, your BOMs will be updated in the production version. So this is important because we are only selecting based on the production version. So this is for the BOM provider. BOM changes through change number we have already discussed. What needs to be done? We have to select and then run two reports to update the valid to date in the two tables, STPO and STKO. Then the change numbers will be effective. So that is the discussion that we are having. 5 minutes time I am taking. Now you can have your questions here. You can list down the questions that you are having on this. So whatever I have told you is each and every report and programs are important while considering the migration. Right now we are not migrating, but I am just telling you which are the simplification items to look at and what are the restrictions. So if you have any questions, you can let me know. Then we can discuss these things, or I can come out with the proposal tomorrow also. You can list out. This is all we need to discuss about MD01 and MD01N.
Yes, Deepak, we can hear you.
Yeah. So tell me, please. Actually, the things that we discussed are the mandatory things that we need to check. These are all pre-migration and post-migration activities, depending on client situation in ECC 6. When we migrate to S4HANA, I mean, whatever restrictions are there and how to take care of those things, and all the enhancement implementations that has happened, and how to optimize and remediate, I mean, custom code remediation in S4HANA, which are the applicable all BAdIs. Those are, there's a most important thing, are not at all applicable. So how to convert those things through this ABAP managed procedures in kernel level program. So all these things have to be kept in mind. I think that there should be a list of all the simplification items and these notes and the correction instructions. All these should be kept in a document. So I don't know whether these are absolutely important and vital from the migration perspective. So I'm not sure whether you will get these details. I mean, this is absolutely necessary for you to keep in a document so that you can execute these steps one by one. So any questions on that or any concerns so far? So if you have no concerns, let us proceed further. My plan is like some handy materials are available with me, which I can show it in the screen and show you. So other materials I am awaiting. So to proceed further, because these are all have to be collated by me. So what I can do is that while I await the materials provided by them, I'll do one thing. I'll go to this topic, demand-driven MRP concept. Since we already know MRP and we are into S4HANA now, at least the concept part I can present you as much as possible today, and we'll continue tomorrow to complete this. And also the MRP procedure changes further with regard to external procurement, simplified sourcing, that will complete tomorrow. These two. I mean, a bit of, the sequence may be different. But before we run these procedures, we will have a session on Fiori apps. So let me see if I can show you the concept of demand-driven MRP. Actually, this is a thing that I have made earlier in the other projects for a customer POC. So I'm just going through. I'm not sure anybody can share this document. I mean, nobody can, in fact. And so I'll just show it in the screen. So let us go through the concept first. Then while doing the demo in the system, that will be recorded and you will be able to do later on. So the first part is the concept of DDMRP. So if we look at it, our normal PD type of MRP, mostly we have been using in ECC 6 or ERP system, has these 5 steps. We have the bill of material, we have the overhead inventory, we have the scheduled receipts, and we have the critical items, MPS items. So MRP takes into consideration all these things and creates the replenishment proposals or orders and generates exception message. So basically what is happening here is step 1 is the netting of all 4. So net requirement that we calculate is the total stock or the inventory plus our expected receipts and firm receipts and minus the requirements, expected requirements from customer requirements or PIR, depending on the planning strategy. And then employ the lot sizing procedure to generate the lot size, that is the quantity, and then do the time phasing, that is the offset that is required to obtain the below level materials beforehand, and the times, lead times, which is the most important thing, lead times to determine the below level materials. We do the bomb explosion and generate the gross requirements of any required components in the next level, and we go on the iteration of these steps until all levels are processed. For each level, we do this. So what are the problems that we are facing with this? Problem is the supply chain nervousness and the volatility of the system. Main thing. that is materials having a long procurement lead time will add to the nervousness because they may not be available before production at the next higher level. So if we look at the factors of factors are supply chain complexity. When it started way back, 50 years back, there was no such complexity. It was low. The product life cycle was long. Customer tolerance was low. Product complexity was low. Product customization was low. Variety of product was low. Long lead time of product was few. Long means why it was few? Because first thing, the product complexity or product variability was low. So less number of products to consider the lead time. So since we were working with less variety and volatility, our forecast accuracy was much better. But all these things have changed in 50 years because the supply chain, due to variable product and different operations, has become highly complex. Life cycle of product, customer tolerance, product complexity, all this has changed. Complexity is high, customer tolerance is low, product variety is high. Now, due to these changes in the supply chain, our long lead time of parts, this is many now. We have to deal with many parts which is having this long lead time. So all these factors, what is the implication of this new normal? The implication is that we have elongated and fragmented while customer tolerance had dropped. That means to reduce the customer, to improve the customer tolerance, we have to ensure, we have to hold these stocks at some strategic point. Now it has become a must. So that means strategic means what? We have to identify materials which are having the long lead times and do a strategic inventory for these materials. So our planning horizon has become further from the actual demand realization. So longer range of forecast has come up. The products having shorter and shorter life cycle or shelf life, and more use of common components. All this means we have to manage stock positions for effective capital and resource management. That means ideal situation is to hold the stocks at all times for materials which are having a long lead time in the supply chain. And for this, it is necessary to have a detailed item level forecasting, and that is very difficult. So with complex planning and supply scenarios than ever, the past is not a good predictor for the future. So the y-axis is the parts which are in SKU. So these are the ranges. So we have an optimal range, which is green. We have a warning thresholds, and too much and too little are the areas which are undesirable. So there is an oscillation. There are two curves. One is an inverted bell-shaped curve. So we see that there is an oscillation between these two limits and the optimal range. This is basically a statistical bimodal distribution of inventory, which is basically making the product oscillate between the ranges, and that means the supply chain is not stable. So effect is persistently high inventory. Second, chronic and frequent shortages. Third is high expedite and waste related expenses. So how much we can have so much inventory and not be able to ship the orders? That is a question. We paid for the last freight, now we don't need it. So that leads to the nervousness of our conventional MRP. So conventional planning, to trigger MRP, conventional planning requires the demand signal. The MRP essentially uses two types of demand. That is, one is the actual, that is maybe from sales order or customer, and another is forecasted, maybe PIR or customer requirement. Use of forecast demand is a choice. So why MRP have to depend on a forecast? MRP is a perfect calculator to balance. So MRP in a forecast is a calculator to balance the requirement with supplies, but it assumes one thing: there is enough time across dependencies. That means we have enough time to produce. That means we assume that the materials for production, raw materials down the line, will be available in time, as per the scheduling dates determined by the system. So the total procurement time and cumulative manufacturing time is much greater than sales order visibility horizon. So to compensate, MRP plans forecast demand signal in an attempt to have the right things at right time. We get the forecasted figure from sales and we do a make to stock. But that leads to inaccuracy.
How it leads to inaccuracy?
Because we will be having a demand created on the forecast, and we'll have the procurements and we'll have the production. But that is done over a planning horizon. But maybe the demand that is based on a forecasted thing.
No.
Not the
Raw
if the
once
actual
we
thing changes. If the actual thing changes.
Once we put the forecast, so raw material, everything procurement has been done based on the forecast only. So whatever the raw material required for that finished good, so that will buy based on that forecast quantity. So it will explode the bomb. So then how it will be inaccuracy means still I'm not able to understand.
That is when the actual figure comes, the actual demand comes. By that time we have procured. And that will
so that, for example, if we put the forecast of 1,000 quantity and we receive the sales order of 500 quantities, so then 500 forecast will be left when that is okay. So that point of view, you are telling this is inaccurate or what?
Exactly, because there will be an over inventory now, because that is not cost effective and that is not optimization. That is the inaccuracy I'm telling.
But this is not a system inaccuracy, no? It is a planning inaccuracy.
This is not a system inaccuracy, but this is how you are. But system means you are calculating in the system the parameters based on your inputs and the parameters that you are maintaining in your BOM and material masters. That is how the scheduling happens and the system calculates. But the calculation of the system is not wrong. That is as per the given algorithms. But considering the fluctuation of the demand, this type of calculation is not taking into account the fluctuations. If the thing that for which we have done the forecasting has changed, if the sales order does not come at all, then there is an over inventory. This is the existing. That was what was existing.
No, but they can they can adjust that inventory for next forecast, no? So, or no?
They can adjust, but again, that when they can adjust, that also will be based on a situation we don't preempt.
Okay, go ahead.
Let me go with these slides first.
Yeah, yeah. Go ahead.
So that is what is the nervousness? The characteristic of a MRP system when minor changes in higher level, that is say at the top level or a sub-assembly level, records or the master production schedule, that will cause significant timing or quantity changes at a lower level. That will happen. That happens with materials having a long lead time down the line for raw materials. So that is why our this planning or forecasting. So what is the present solutions? That is frequently MRP has to be run and we must have a weekly bucket. But more frequently we run, the system will change. It will adapt to the new situation. So in order to do a damping, MRP is run less frequently. Not every day, maybe there are two MRP runs, maybe. One is monthly and one is having a daily run. Those who are not having this type of demand-driven concept, see, actually, if you ask me, no system is foolproof. We know that DDMRP also is 15 years old and there is a change in the version. And after not fulfilling this, predictive MRP has also come, which I have not employed anywhere. I don't know, but it has also come. Why it has come? Because of certain things which are not made by this one. So this is one of the solution. Another is the flattening of the BOM. That means the number of levels in the BOM. If we can limit the number of connections, how we can do? So that means semi-finished levels are dispensed with, or certain SFG levels are dispensed with and directly going to the raw materials level. Reduce the number of connections. Main point is the right material is not ready at needed time. This complaint we receive from the clients. So this gray area part, that is MRP plans never properly synchronized with all levels. Variability in one level is not immediately reflected in the another level. The supply variability cases delay accumulation across dependent network. And MRP plans are built using dependencies. So these gray areas that leads to this right material is not available at needed time, and this delay across levels accumulates. So the facts are normal and random variations exist in every process. So our this process is still deemed to be at steady state as long as variations are within calculated control limits. That is the warning limits we have seen. But steady state does not mean that there will be no variations. But it will be within the control limits, but the variations will be small. So many components can have good availability, but it only takes one or two serious implications to change that for the parent. So basically an extreme change in the supply position upstream in a supply chain generated by a small change in the demand downstream in the supply chain. So inventory can quickly move from being back ordered to being excess. So this is caused by a serial nature of communicating orders up to the chain with the inherent transportation delays of moving product down the chain. These are all demand-driven MRP concepts introduced by J. Foster in 90. I'm not going to the theory aspect. This part. What SAP has done in the DDMRP, that is more we are interested in. The demand signal distortion flows from final assembly back to the foundry and the supply in the other direction. And if there are more parts in the supply chain, then the situation is worse. These are all theory. I'm not good. So demand-driven MRP is a model. It plans and manages supply chains to protect and promote flow of relevant information and materials. DDMRP uses strategic decoupling points to drive supply order generation and management throughout a supply chain. So DDMRP has 5 components. First is the strategic inventory positioning. That means there has to be a strategic decoupling. When we see a BOM structure and connections, so we calculate the lead time of each of the components as we go along the chain. And components having the highest lead time of procurement are strategically decoupled. Means they will be excluded from the MRP procedure and we'll have a buffer profiles. We have to calculate a buffer level for this. So that is called the strategic inventory position and strategic decoupling. Then we'll have to do a dynamic adjustment, do the planning run and see the width of different zones, the 3 buffer zones. So basically, it is earlier we have 2 questions: how much inventory to hold and when to reorder. So in DDMRP, the focus is where in the supply chain or within the company the position. First thing is the positioning. Where in the supply chain or within the company the position of the inventory. What can happen? We can have a reduced total inventory. We can compress the lead time, less disruption, increase overall stability, increase overall agility and protection of performance of critical resources. So once we are able to do a positioning or strategic inventory, after decoupling and we do the buffering. So basically, the concept of strategic inventory positioning called a decoupling point that breaks the connection between dependencies. So creating independency between supply and use of material. Commonly denotes providing inventory between operations so that fluctuations of the production rate of the supply operation do not constrain production or use rates of the next operation. So it does not hamper the production or delay the production when we have a strategic decoupling. The location of the product structure, the decoupling point or distributor where strategic inventory is placed to create dependency, that is called the decoupling point. Decoupling point between sub-assembly and final assembly. We have the foundry, we have the component. from foundry, then the sub-assembly is done and final assembly. So where we will put the strategic decoupling point? It will have to be placed somewhere within the supply chain. So we have to consider some factors while doing this strategic inventory positioning. We have to consider customer tolerance time. The customer willing to wait for the delivery of a product. Market potential lead time, the lead time that will allow an increase of price or the capture of additional business through either existing or new customer channels. Demand variability means potential for swings and spikes in demand that could overwhelm resources. Then supply variability, the potential for and severity of disruptions in sources of supply and or specific suppliers. This can also be referred to as supply continuity variability. Inventory leverage and flexibility, the places in the integrated BOM structure or the distribution network that leave a company with the most available options and a base lead time compression to meet the business needs. And critical operation protection is the minimization of disruption passed to critical resources and control points. These factors are to be considered while deciding on the decoupling point. So what are the lead times in supply chain? One is the purchasing lead time. It is the lead time to obtain a purchased item. This is the your planned delivery time, then GR processing time, transportation time, receiving inspection, put away, all these things. Manufacturing lead time, that includes the actual order preparation, preparation time, queue time, wait time, setup time, run time, move time. Then after GR, the inspection time and put away. And the cumulative lead time is the longest planned length of time to accomplish the activity in question. It is found by reviewing the lead time of each of the bill of material part below the item. Whichever part adds to the greatest number defines cumulative lead time. And then comes the ASRLT, which is the actively synchronized replenishment lead time. The longest unprotected or unbuffered sequence in a BOM for a particular parent is called the actively synchronized replenishment lead time. Longest or unprotected, unbuffered time. Let us take this example. One FG, then SFG, further SFG, and raw materials. These are the just one second. These two lead times that we defined in the last slide, this MLT and CLT, manufacturing lead time and cumulative lead time, these are the extreme measures of lead time. To make MLT a realistic planning input, manufacturing time, all components at lower level would need to be stocked and reliably managed so that they are always readily available. This is the point. There should not be any production, delay, means between the operations. As we move along, the material should always be available. At cumulative lead time, assume that no components on the longest part will be available, making it very unrealistic. We have the manufacturing lead time for the finished good is 2 days. So cumulative lead time for FG is 26 days. In the circle, these are the days. That is the maximum time. We have to go through this chain. You can calculate whether this 2, 7, 3. You can calculate the time. This is 11 days. 4, 15, 3, 18, 22, 27. If we follow the left hand, the first one, this first chain, this is 26 days. 7, 4, 11, 7, 18. The longest time, that is 26 days. That is the blue part. So initially your ASRLT is the last terminology, this one, which we used. Actively synchronized replenishment lead time. So FG initially we find that ASRLT is 26 days, that is the maximum. So maintain some stock of say 501, which has the highest lead time. So that is our decoupling point. So this 11 days become 0. 0 or changed. Now we recalculate. We maintain some stock for RM 501 and we recalculate which is the longest one. Now 7, 4 and 7 and 2. So that makes it 20 days. Now, if we maintain stock of 403, SFG 202, SFG 202, SFG 301 and RM 302, ASRLT becomes further less. Because these stocks are there. So now the lead time has become this. So we don't have to procure this. RM302 stocks is also there. So it is only 6 plus 2, 8 days. And we can calculate the stock of ASRLT similar way, considering the stocks. So that means basically we have to decide on a strategic decoupling point to reduce the synchronized lead time. This is the first step of strategic inventory positioning. So we have to create a BOM matrix where we have in the row different columns at the top row all the products having the parents. And to produce these products, the components, we have to write in the items in the different rows and enter the times there, procurement times there. So purpose is to find the decoupling points by comparing BOMs of different parent level items by looking at whether there exists any shared components between these, which can be stopped so that it can affect all the FG productions. So any component in the synchronized lead time path that has to be identified. That is the primary focus for multiple parent items. That is going to give us the greatest benefit and inventory reduction and reduction of lead times. Now, if the parent material is to be stocked, then we have to, our objective is to reduce the inventory. And if it is non-stock, then we have to reduce the lead time. Now, once we decide and identify the decoupling points based on this synchronized lead time calculation, then we have to make decoupling points. That is, we have to create the buffer zone width and we have to define buffer profiles first. To calculate the width of the buffer zones, there are 3 buffer zones that will come to. We have to define the buffer profiles first. It is a group of settings or characteristics which are having the same attributes. Say, for example, item type, lead time, variability. So I'm coming to these buffer levels. There are some terminologies here. So stock buffers are sized to a number of factors. So first you can see the 4 buffer zones. The excess zone is above the green zone, which is the OK zone, where we have the sufficient stock. The yellow zone is the zone where we have to rebuild. And red is the base limit, which is the alert zone. And further, another red is there, which is the stock out zone. And below that is the black zone. No stock. Now, objective is to increase the width of the green zone to an optimum level. At the same time, there should not be excess. Or we have to optimize also the width of the yellow zone. So do that, some factors are considered. One is average daily usage or ADU, which is calculated using a rolling past horizon. This ASRLT, that is the active synchronized lead time. Location of the parts for distributed parts. And what is MOQ? MOQ is a factor. The buffers are arranged in 3 color zones, red, yellow, and green. Each zone has a specific purpose and vary in size and proportion depending on the buffer profile. Now, buffer profile has to be calculated. The green zone is the heart of supply order generation process embedded in the green zone is determined by the three factors. How does the width of green zone gets calculated? The percentage of ADU over one full is ASRLT, significance of MOQ if applicable, and impose minimum order cycle if applicable. The greatest number determines the size of the green zone. So calculating the green zone as a percentage of ADU over these things which is there in this slide, these are actually calculated in a Fiori app called buffer zone calculation that we'll do in the system. So calculating the green zone as a percentage of ADU over ASRLT requires knowledge of what lead time category of SKU belongs, whether it is a short time, medium time or long time. The recommended percentages of lead time factors are long lead time 20 to 40% of ADU. Medium is 41 to 60% and short lead time is 61 to 100%. Average daily usage. It is also called a lead time factor. The longer lead time of the SKU, smaller the lead time factor. And smaller lead time factor means green zone, smaller green zone and frequent ordering. Now in MRP approach, we have large infrequent orders. And in DDMRP approach, we have small frequent orders. That means the width of the green zone should be calculated that way. The DDMRP approach forces as frequent ordering as possible, so width of the green zone should be less. And that means smaller lead time. Let us take an example. Average daily usage is 10 per day. Active synchronized replenishment lead time is 12 days. So from that, we have a lead time factor of 50%. Our lead time category is medium and order cycle is 7 days. MOQ is 50. So step 1, calculate the size of the green zone using lead time factor, which is average daily usage 10 per day multiply by ASRLT, that is the lead time in days, multiply by the time factor, which comes to 60. Step 2, compare calculated green zone against MOQ, which is 50, and that is less than the MAQ lead, we have given as 50, and that is less than the calculated green zone. So that is 60. So we are going with 60. Third step, compare calculated green zone against imposed order cycle. Now, order cycle is 7 days. And average daily usage is 10 days, 10 per day. So order cycle factor is 70. So order cycle factor is more than the green zone. So highest of these three will be the width of the green zone. So our green zone will be 70. And the order frequency, that will be green zone divided by ADU, that comes to 7 days. So that is how between these three we calculate the green zone size. Second, yellow zone is calculated as 100% ADU over ASLRT. ADU was 10, ASLRT 12, and 100% of that is 120. So that is our yellow zone. That is calculated as 120. The red zone is the embedded safety in the buffer. the higher the variability associated with the part or SKU, the larger the red zone will be. So calculating the red zone requires 3 sequential equations. This is very important, calculation of red zone. So the base of the red zone is average daily usage multiplied by ASRLT into the lead time factor, that is 60. And this lead time factor corresponds to the same range. Short, medium use for green zone, same, but can have a different actual percentage of what green zone had used. And the rate safety is rate calculated as a percentage multiplier of the rate base. So rate base is 60. That is called a variability factor. And for high variability, these factors will be fed into our system to calculate the, and we have to get these factors from the system. We have to calculate from the client requirement, these factors. So variability, this high variability, medium variability, and low variability are defined here. And accordingly, the rate safety will be calculated as a percentage of the rate base. And this variability is measured by what is known as the coefficient of variation. The coefficient of variation is the standard deviation of demand or supply divided by ADU. The coefficient of variation distribution decides whether the part of SKU belongs to high variability or medium variability or low variability. For low variability, the variability factor is generally 33%. So rate safety will be rate base into 0.33, it is 20, and total red zone will be 20 plus 60, that will be 80. So red zone is 80, yellow is 120, and green zone is 70. These are the formula for calculating the zones based on those elements. So first step was identifying the strategic decoupling point. Second is the calculation of the buffer levels and the width of the zones. Now we have to do a dynamic adjustment. So first is recalculated adjustment that can be done into it either by using average daily usage based adjustment or by using zone occurrence based adjustment. Average daily based usage adjustment is the past consumption of stock keeping unit is recalculated by using rolling time horizon. So we have an available stock position against average daily usage. So the recalculated adjustment, zone occurrence based adjustment, their average order interval is defined for a part based on demand and lead time profile. And if the occurrence is not according to the average frequencies and adjustment made for the buffer profiles. Let us see the calculation. And second is a planned adjustment. That is based on forecasted ADU. Third is the manual adjustment. This ADU manual adjustment we do in these Fiori apps. So we have the threshold, ADU alert threshold, ADU alert horizon. These terminology, this we'll see. So once we do the adjustments, then comes the next point, that the demand driven MRP run and how the net requirement is calculated. That is, in our MRP calculation, we have the net requirement calculation. So here we have a net flow equation. So our next is what is I am having, and what demand do I need to fulfill immediately, and what is the future demand. So net flow equation will be on stock hand plus open supply minus qualified demand. Qualified demand is the actual demand or not the forecast demand. Now, if net flow is less than top of yellow, a supply order is generated. And the supply order quantity will be top of green minus net flow. So net flow is less equal to top of yellow, then the order is generated, and that will be top of green, the quantity. Minus the net flow. And what is a qualified demand? A qualified sales order demand is the past due sales order, today's due sales order plus spike. Now, what are qualified spikes? So qualified spikes are demand peaks from customer orders which will be delivered in future. So we have spike horizons and order spike threshold which have to be defined. So spike horizon is the order spike horizon, which is equal to the actively synchronized RLT. That is the time horizon for monitoring of future demand of SKU. And threshold is the limit of demand what is allowed to be in the horizon without being qualified as order spike. So order spike threshold will be our red zone into the factor, and this factor is 0.5 generally. So that is our qualified sales order demand. This is past and future where spikes are not considered. So we have to define a spike horizon, and within that spike horizon, we have the order spike threshold, which is the red base into 0.5. That is the height of the spike horizon. And we have to consider this as qualified orders. So if we consider the bomb explosion in case of MRP and in case of DDMRP, so when a supply order is generated at a higher level, decoupling stops the explosion of bomb at decoupling points. So in case of DDMRP, which we did not have in the MRP explosion. So there is no bomb explosion because of the coupling point is buffered. We have maintained the stock level after calculating the zones and accordingly we have maintained. And that is why the final net flow calculation and the order quantity and date, these are calculated based on those equations depending on the buffer zone. The consumption and demand is accumulated at a point until resupply is recommended through the net flow equation. Which point? The decoupling points. The explosion then begins again relative to the parts respective component. The concept is preventing nervousness because here we assume that at the decoupling points we have the sufficient buffer. So this is basically a decoupled explosion. A distinguishing characteristic of DDMRP system. It is important to understand that there is independence. That means in this decoupling points, that is, the entire supply chain, this procurement cycle, that is independent of the decoupling points. It is delinked.
Deepak, just one request. I think today is enough.
No, actually, what, let me tell you one thing. Let me tell you one. Let me, I understand this. I understand. I mean, let me tell all of you one thing. Actually, this DDMRP concept and theory is already there. You can look at a resource called Demand Driven Institute, who has come up with this concept long back. That is the theory. But in SAP, this G1 MRP type, which we'll be using, is actually using 6 Fiori apps for decoupling, buffer profile level calculation and adjustment. These first three, they are tackled by 6 Fiori apps. And then this MD01N run will happen with the MRP type D1 for the demand planning. And we'll see the effect. Actually, this makes, difficult, but we need to understand, this particular slide, which I'm showing you, presentation, this you should have. Because later on, this formula, the same formulas will be used.
That we will continue from tomorrow. What about others? सब ऊपर से जा
If
रहा है.
required, I can go through some parts again.
Thank you.
And very crucial is that it will be a wastage of today's time if we don't have the documents for the first part. I mean the simplification items and the steps. These are absolutely vital steps. You must keep a document handy with you. Otherwise, this will be of no use. Please ensure that this training material is available. As soon as possible. Okay. So any question, any other questions on this? On the first part, I'm not talking about DDMRP, you have just started. Any suggestions or any feedback?
The MRP live just want to see in the system. You showed that the programs, so many things you showed us.
So let us do one thing. Let me complete this slide. Not much is left tomorrow. And then before doing the MRP run in the system for DDMRP, we have to go through the Fiori apps first. Yeah, because these are all Fiori apps based configurations. So we'll have a session on Fiori apps. Then we'll do the DDMRP run in the system.
For DDMRP, that is okay. For Fiori, I just want to say the MRP live.
MRP Live, lot of Fiori apps are there that each one will see. MRP
Okay.
Live run, you can see in the system. You can right now, if you do MD01N with a host of plants, you can see that log. You will not see any difference between what is happening in MD01 and MD0M. The recommended thing is that minimum number of materials is 100, after which you can see the performance improvement. That is the basic objective, and the simplifications and the reductions in number of fields to be maintained, and the number of tables. You can see that many tables are combined into a single one.
Okay.
So tomorrow we'll continue.
Sure.
Okay. Thanks.
Thank you. Thank you, Deepak.
Okay.
Thank you.
Yeah.
Thank you.
Thank you.
Thank you for attending the session. I hope you all enjoyed it. Don't forget to like and subscribe to our channel. Also, feel free to ask your questions in the comment section below, and we will reply to them at the earliest.